Welcome back to Function Transformations. Last class we talked about translations, moving things left, right, moving them up, down. Today we're going to talk about two concepts. One is a reflection and one is a stretch. We've seen both of these with parabolas limitedly before, and really only vertically. So we're going to look at this vertically with parabolas to get a sense of what's going on, and then we'll talk about how that happens horizontally as well. For starters, take a moment to graph these three things. I'm going to do this here as well. We have our parent function y equals x squared, and then a couple of different versions of it. We'll talk about what happens there. Back. Wait. So there's our parent function, and let's use, sure, pink's a great color. I'll use that. For y equals 2x squared, it's like, I remember that's taking all these and multiplying by 2. So we still have this, but that times 2, and then 4 times 2. All right. Connect the dots with that. So we recall that that gives us kind of a steeper parabola. It's got a much sharper turn at the bottom. It's like we've taken that original parabola and just yoinked it straight up. Whee! That one. Let's get ourselves a purple parabola too. I'll make that one purple. And half of x, that means I'm taking all these and halving them. 9 turns into 4.5 there. I will have to label my scale at some point. So this parabola works much more gradually as it changes. Still changes, still has the same kind of general property of arcing, but how quickly it does that, how steeply everything changes, that's different. So we've got these three parabolas. We've got our parent parabola, this y equals x squared here, but then we've really stretched that whole thing out to get the pink one and really kind of squished everything down to get the purple one. So what's the dealio? Well, we know that there's a vertical stretch factor going on. We know that I know how to select the color blue. There it is. So this is some sort of multiplier, and it's multiplying not the x values, but the y values. So when y equals 2x squared, we had this one that had a value of 4, multiplied by 2 to give us 8. Or 1 times 2 gives us 2. Or 0 times 2 gives us 0. In the other case, where y was half of x squared, we multiplied by a half. We had 4 times a half gives us 2. We had 9 times a half gives us 4. And I did mention that I need to indicate my scale like a good mathematician. So in general, when we're multiplying by some value a, we can say that we'll multiply the y values by a. We can say a few things here. One thing we can say is that we'll multiply the y values by a. Or how do we compare the graphs? We can say that the y values have been multiplied by a. Effectually, what do we see? We see stretches, or we see kind of squishy downs. We see a stretch with a value like 2. We see a squishy down, or a compression, with a value like 1/2. Because when we multiply something by 2, it gets greater. When we multiply something by a half, well, I mean, half a pie isn't as much as a full pie, or half a cake, or whatever it is you're multiplying by half these days. So there's formal ways to refer to these. When we have y equals 2f of x, we say that there is a vertical stretch factor of 2. But if we're talking about y equals half of x, well, we could say that there's a vertical stretch factor of half. We do see a compression, really. And if you're going to talk about the compression, it'd be the reciprocal. So a vertical stretch factor of half is a vertical compression by a factor of 2. Those are vertical changes. There could also be horizontal changes. And just like we saw with translations, horizontal changes are happening when we modify stuff inside the brackets. So anything outside, this is outside the f of x, this is outside the f of x, that's a vertical change. But here we're contained in these brackets, And what that does is, of course, well, make things change horizontally. It affects the x values. One thing we saw with translations is that the function kind of behaved in an opposite manner to what we expected. When we saw f of x minus 3, we ended up adding 3. When we saw f of x plus 7, we ended up subtracting 7. Similarly, we see opposite behavior here from what's expected. If we see 2x, we expect ourselves to multiply, but instead, that compresses things. And similarly, well, you're right, I should highlight this. I do have that ability. When we see half of x where we'd expect, well, that's going to make things smaller, it actually stretches things out. So we could still phrase it as a horizontal compression, but we would really see a stretch happen. So we could say that there's a horizontal stretch. And if we look at parabolas, what was the effect when the value of a was negative? So if we looked at like y equals negative x squared, or if we looked at y equals negative 2x squared, we know that that would, instead of giving us our happy parabola, give us a sad parabola. The frowny face out of it, to feel. So what that does is it gives us a reflection. It causes us to have to reflect this parabola over this x-axis here. Colloquially, we could say that it flips the graph upside down. But formally, we're looking at this language. So when the value of A is negative, we're talking about a vertical reflection over the x-axis. And similarly, get right out of here. If we're looking inside the brackets, like here, that's also going to cause a reflection. But it'll be horizontally. So the lefts will become rights, the rights will become lefts. So let's use our words to explain what's happening here. Here, something outside the brackets, we're talking about something vertical. Vertical acts exactly as we expect it to. So we're just going to multiply everything by 2. We will see a vertical stretch. In this next one, we've got a couple things going on. We've got this negative out here. It's outside, so that's a vertical effect. Vertical reflection about the, well, let's see, if it's vertical, it means you're turning this into this. We're flipping things over the x-axis. And this business here, inside the brackets, we're not going to stretch things out by 4. We're going to compress it. Hereabouts. We're multiplying all the y values by 2/3. We can phrase this a couple ways, but if we want to be consistent, we'll just say that's a vertical stretch by a factor of 2/3. You could also say this. So it's compression by the reciprocal. Whatever way works for you, go with that. In here, well, it's just like the last example. It's horizontal, for starters, because it's inside the brackets. And secondly, it's a compression. And this last example, we've got a few things going on. We've got this. And then we've also got, oh, what's a good color? Let's talk about just this for starters. A horizontal compression by a factor of 1/2, which we could also say is a horizontal stretch by a factor of 2. And then finally, there's one other thing going on, and that's this negative right there. going to cause a horizontal effect because it's inside the brackets. Because that's that negative, that's going to cause a reflection. And if this one causes a reflection about the x-axis, well then the one we're dealing with here will cause a reflection about the y-axis. And it's to say if we're going to flip something from being here to being here, the y-axis is the line it's flipping over. So it's horizontal, but we're still invoking the use of the y-axis for that reason. So we're going to apply these. We're going to try applying these transformations. Here's f of x, and based on f of x, we're going to graph these other ones. Feel free to give it a try. Again, pause the video, then go for it. I will show the answers on here. And also feel free to use your words. So as you're doing this, you can certainly write out what transformations you expect to see happen and go from there. That might help just delineate what exactly you have to actually do in this. So if you're going to pause now. I'm going ahead. I'm going to do a vertical stretch. By a factor of 2, which effectually means I'm multiplying all my y values by 2. Here we had 0, staying 0. Over here, that was 2. I multiply by 2 to give me 4. Over here, that was negative 1. So I multiply by 2 to give me negative 2. And then down here, it was negative 4. Multiply by 2 to give me, multiply by 2 to give me negative 8. So all my new y values, I'm just getting by multiplying the old y values by, 2. Boop. Hey now. That went right through. That's that one. So we can see how it was stretched over the x-axis. And this next one, I see this as a horizontal compression by a factor of 2, which means I'm going to take my x values, divide them by 2. X value of 0 is still 0. X value of 2, divide that by 2. I've got 1. X value of 4, divide 4 by 2, I'm at 2. X value of 6, divide that by 2, and I'm at 3. So I'm getting all my new x values by taking the old x values and dividing them by 2. And from there, connecting the dots. Because this has straight lines to begin with, you might want to make sure you're using a straight edge of some sort, whether that's a ruler or a piece of paper, doesn't matter, just make sure that the straightness is maintained. Last one, couple things, okay. Couple transformations happening here. I see this. Which is a vertical compression. And I see this, which is a horizontal reflection. I will do them in that order. So I'll tack one, then the other. I don't have to do them both at once. But anything that's not my final product, has to be a dotted line. So when I apply this vertical compression, for example, and I multiply all my y values by 1/2, I'll plot my points. But when I connect these dots, I'm using a dashed line. This is not my final graph. It's just a step along the way. Then when I apply my horizontal reflection, I'm going to take this thing and just kind of flip it the other way. I'm going to reflect it. Looks like this is still there. This, which was at -4, goes to +4 on the other side. Why do I still have this here? That's disgusting. There we go. And then when I connect the dots here, because this is my final answer, that can be, yikes, that can be a solid line. Oh, goodness gracious. That was the whole end of the topic already. Thought we had like 80 more examples. Well, that's kind of nice. For me anyways, it means I can stop talking, right? So there's some practice for you. Practice those questions. Give it a go. Give it a shot, give it a stab. What we'll be doing in one of our next classes, or the next lesson, is combining those transformations. So we'll be taking translations and stretches and reflections, and we'll just be mashing them all together. So you'll want to make sure you're comfortable with translations. You'll want to make sure you're comfortable with stretches and compressions. You'll want to make sure you're comfortable with reflections before moving ahead. So again, if you have questions or comments or concerns, please make sure you get those addressed either in class or by contacting me, whatever it is you need. And have a good day. Believe in yourselves. Believe in the dream. Goodbye.